Hello everyone, welcome to Gchem classes. Okay, so today will be the last lecture. Today only PYQ I am going to discuss it. So already I have discussed for 2022. Okay, now 2021 I am going to discuss it. So two questions already I have discussed. Then remaining questions I am going to discuss it in 2021. So let me see the question number 15. Okay, so what is that question number 15 from 2021? You can see in the screen the decreasing order of carbon-carbon bond length in the following complexes. Okay, so all are alkene. So it is asking that the bond length. Okay, which one is lesser bond length into the decreasing order? It is simple. The decreasing order it is asking. So I'm not going to write the entire compound. Just I'll write in compound one what they want to mention. It is like it is platinum, and then both are hydrogen, correct? In this way I am framing because one is having platinum and then all are cyano group. Okay, and then third one we have platinum, and then we have fluorine, hydrogen and hydrogen. Okay, then fourth one we have platinum. Okay, then fluorine. Okay, these are the four structures. In that you have to see which one is having carbon. These are the carbon, right? Carbon and carbon. So which one is having the like more carbon bond length? Which one is having lesser carbon bond? How you are going to find it out? See the approach. Okay, here it is minus I effect. So how many minus I effect is there? 4. Here it is here it is minus R effect. How it is minus R effect? We'll see. One will explain it. This is nitrogen. See, this bond will shift here. Then to neutralize this carbon, this bond will be shift here. So here resonance is happening. Okay, so it will be minus R. Okay, so minus R. This one is minus I, and here also it is having minus I. Here nothing is there. Here it is no minus I, no plus I. Okay, it is a normal in this condition. It is normal. So now you just see if from all the four sides electron density is pulling. See, this double bond means what? This one sigma bond is there. Remaining is like one more. Like the remaining one is pi bond, right? So pi bond means it's the electron cloud. Okay, top and bottom the electron cloud will be there. So if this fluorine, this is the electronegative, more electronegative element is attached to this carbon, alkene carbon. So what it will do, this electron cloud, it will pull towards this more electronegative element. Okay, fluorine is a more electronegative one. So it will pull. So if it is pulling, then this pi electron cloud will decrease, right? If that pi electron clouds is decreasing, then it will behave like a single bond, right? It will behave like a single bond. So likewise, here it is due to minus I effect, but here it is due to minus R effect. So if minus I is also present and minus R both are present, then what you have to select anyone. Which one you are going to select it? Means which one you are going to give priority? You have to give priority for minus R, okay, and then minus I. So in this case, this bond length will be more compared to this, right? So in this case, second will be having more bond length, carbon bond length. Then we will have for 4. Okay, and then we'll see this one will have, because this is also pulling out. Okay, so third, and then finally we will have the smaller one will be first. So which option is belonging to this the arrangement? So option C, right? Second, 4, and then third, and then 1, right? So option C will be your correct. So next question will be your question number 17. Okay, let me check this there in question number 17. You can see in screen, right? The question you can see in screen. According to the crystal pure theory, DD transition observed in the complex is titanium, H2O, hexa aqua, okay, and then 3 plus. So this will contribute zero, like zero charge it will contribute, but it is only lone pair it is contributing, right? So what will be the oxidation state of titanium? Titanium will be in +3, right? So Titanium in +2 oxidation state, it will be 2 D2, right? D2. If it is +3, then it will be D1. So now D1 we have to just draw it. Okay, T2G, EG. So we have one electron, right? So now what is happening? It is going from here to here, right? So this we call it spin allowed. Okay. Okay, spin allowed. Correct. But what about Laporte? Laporte, so delta L. Laporte is delta L. Delta L, it should be equal to plus or minus 1, right? So delta L we are not changing here. Okay. Here orbitals is not changing. Okay. It is in D itself, right? If it is coming from P to D. Okay. If it is coming from P orbital to D orbital, then it is Laporte allowed. Correct. But here it is delta S equal to delta S equal to 0, right? If it is delta S equal to 0, then it will be spin allowed, correct? Okay. If delta S is not equal to 0, then it won't be spin allowed. So how to check whether delta S is 0 or not? Okay. See, here also it is plus half. If it is going up, it will be sit like this. So here also it is plus half. So plus half minus and then plus half, it will be 0, right? Suppose here it is plus half. So plus half. Okay. Okay, how much? So spin multiplicity we have to check. So here also it is plus half, here also it is plus half. Let me check for this one. For suppose this one is S and you write T2G. Okay, so how much it is coming? It will be 2 into half plus 1, right? It is cancelled out. How much it is coming? 2. Let me check for S and then EG. When it is going to here, how much it is coming? 2 into half plus 1. So 2 and 2 get cancelled. So again it is 2. So delta S equal to 0. Okay. Delta S means SEG minus ST2G. How much it will come? 2 minus 2, it will be 0, right? So we are getting 0. Correct. So if we are getting 0, then it will be spin allowed, correct? But if we are not getting plus and minus 1, so we are not getting, right? Here we are not getting because it is going from D to D, right? It is going from D to D. It means it won't be plus and minus 1. L equal to, here delta L equal to 0 it is coming, right? So in this case, this will be Laporte forbidden. Okay, Laporte forbidden. So your option D will be your correct. Laporte forbidden and spin allowed. Okay, Laporte forbidden and spin allowed. So we'll see the next question. So question number 32. We'll see the question number 32 from the same year 2021. Right. So question number 32. What it says, you will see in the screen. Right. The complexes that allow John-Taylor distortion. Okay. John-Taylor distortion. Okay. Already we have discussed, right, JTD. So now we have to draw one by one this complexes and we'll see whether it's a John-Taylor distortion or not. So just repeat it along with me. Just repeat it. What is John-Taylor distortion? If any unsymmetrical form will come, whether it is in T2G or EG, if it is unsymmetrical, then John-Taylor distortion will be there, right? So we'll see one by one. For option A, what is the complex? Cobalt and then cyano. It is 5 times, and then water, here it is 3 minus. So first we have to see whether this molecular arrangement, here you see this will be strong field ligand and this will be weak field ligand. But if strong field ligand is present, it is 5 in number, right? So this will behave like a strong field ligand only. So pairing up will take place. So cobalt, what will be the oxidation number? We'll see it is a 5. So minus 5 it is contributing from here. It will be 0 ion, 0 charge it is contributing from water. So let me check the oxidation number of cobalt. So X plus 5 into minus 1. Okay. And then equal to minus 3. So X equal to minus 3 and plus 5. So it will be plus 2, right? So cobalt is in plus 2 oxidation state. So it will be D7, no doubt. And then we'll see this is T2G, this is EG. So pairing up will take place. So here it is 3 and here it is 2. So let me fill up 1, 2, 3, 4, 5, 6. One more electron is there. So 7th one is here. See here unsymmetric, right? Here unsymmetric means it will give John-Taylor distortion, correct? So this one is giving John Taylor distortion. Option B, we will see it. Option B, it is nickel, okay, and then 2 minus, correct. We'll find it out the oxidation number of this. So fluorine, -1 charge it will contribute, right? So -1 into 6, so -6, total -6 it will contribute. So let me check x, and then plus 6 into -1 equal to -2. So how much it is coming? X equal to -2 plus 6, or x equal to +4. So +4 oxidation state, okay. Whether it's a weak field or a strong field, now it is doesn't matter. If any metal, central metal is having more than +3 oxidation state, then here the pairing up will takes place, okay. So now nickel in +4, how much it will be? So nickel in +2, how much it is coming? D8, right? Nickel in +2, it will be D8. So nickel in +4, it will be D6, correct? So just fill it up. This will be T2G, this will be EG. Okay, so 6 electrons are there. 1, 2, 3. Now pairing up is taking place. So 4, 5, 6. So see, here also symmetry is there. Here also symmetry is there. So there is no John Taylor distortion, right? So this is not having John Taylor distortion, correct? Now A and B is done. So C and D we will see it, whether John Taylor distortion is present or it is absent, correct? We'll see it for C and D. So option C, what is that? Manganese, okay, and then, okay, 6 times 2 plus. So for this, we will check it. For manganese, oxidation number we will find it out. X plus, this will contribute, okay, okay, this will contribute, just draw this molecule NC, okay, and then Me. So this lone pair will contribute, okay. So here there won't be any charge. It is like 0 charge contribution, but 2 electron it is contributing, right? So now what will happen? Let's see. X plus it will be 0 only, equal to +2. So metal in +2 oxidation state. This C and no nitrogen is there and cyano is there, so it will be a strong field ligand. So pairing up will take place. So let's see, D5, and pairing up is taking place, EG. So it will be 1, 2, 3, 4, 5. See here unsymmetric is there, right? So unsymmetric means it will give John Taylor distortion, okay? So this is also giving John Taylor distortion. And then option D. What is option D? It is cobalt, En2, and then F2. Only 1 plus, yeah. This En is a strong field ligand, this one is a weak field ligand. So overall it will take place is a strong field ligand only. We'll see the oxidation number of this cobalt. This won't contribute any charge, so it will be 0. This will contribute charge, so -1 into 2, so -2 it will contribute. So for cobalt, we'll see it. Cobalt oxidation number we are checking. So X, and then plus 2 into -1 equal to +1. Now X equal to +1 plus 2. How much is coming? +3. So cobalt in +3 oxidation state. What will be the number of electron in D? So it will be D6, correct? Now you just see the arrangement. It is T2G. This one easy. Okay, and then strong field ligand. It is behave like a strong field ligand. Okay, whenever cobalt is in 3 plus and nitrogen containing ligand will be there, so it will act as a strong field ligand, and then the pairing up will takes place. Okay, so 1, 2, 3, 4, 5, 6. Okay, so see here also symmetry, here also symmetry. So if it is symmetry, then it won't give John Taylor distortion. Okay, option D is also not correct. So option A and option C is your correct option for this question, right? The complexes that show John Taylor distortion. So option A and option C will be your correct answer. Okay, and the next question number 42, correct? The total number of microstates possible for D8 electronic configuration. Already we have calculated. So for D8, how you are going to calculate? For D, it will be like how we are calculating. It will be factorial. Okay. So with factorial, how much it will come? 10 factorial divided by, this is the number of electron. Okay, 8 electrons are there. So it will be 10 minus 8, and then here factorial will be there into how many are there? Electron 8. So 8 factorial. So that formula you remember, right? It will be n factorial divided by n minus r factorial into r factorial. Here n is number of orbital into 2. R is number of electron present, right? So 10 factorial. So just we have to do multiplication till 8 factorial, we will get it. So 10 into 9 into 8 factorial, and then here it will be 10 minus 8, it will be 2 factorial. So 2 into 1. Okay, and then here it will be into 8 factorial, correct? So 8 factorial will get cancelled. 2, it will be 5. So 5 9s are, how much it is coming? 45. So total number of microstate is 45. So your answer will be 45, correct? So next question we will solve it. So question number 51 from the same year. So question number 51, right? What is that? You can see in the screen. If the crystal field is splitting energy of, okay, they have given crystal field is splitting energy, n is 3, 4 times, this is 2 plus, so tetrahedral we have to find it out, is 59, okay, sorry, it is 59 per centimeter, okay. Then the magnitude of its crystal field stabilization energy. So it is asking CFSE, right? And it is asking in kilojoule per mole. So kilojoule per mole. So this per centimeter we have to change it to per meter, right? So how? So 5, we just write it here. 5900 into 10 to the power 100 multiply by 100, so it will be per meter, right? So this we have converted to per meter. Now for delta tetrahedral we have to find it out. So what will be the formula for delta tetrahedral? It will be H, C, and then this frequency, whatever frequency it has given, frequency, and then okay, this the frequency we have, this one, and then multiplication with Avogadro number. Okay, these are the multiplication. So just we write the value and we'll calculate and we'll keep it up, and then we'll find out what will be the like CFSE value, okay, because that we are multiplying, right, with delta tetrahedral, correct? So first we are finding the delta tetrahedral, and then we will put in that formula, and final value we will get it, right? So H value is 6.62 into 10 to the power minus 34 joule second, and then this C is 3 into 10 to the power 8 meter per second, correct? This is the velocity of light, and then into, what is the frequency here? It is 5900 into 100, and then we have this Na value, right? How much it is? 6.02 into 10 to the power 23. So all together if you are solving this, how much it will come? Already I have calculated and I have kept, so it will be 70.638. okay, this value you will get it for delta tetrahedral. Now next what you have to do it, you have to just find it out for CFSE, like this formula you have to put CFSE equal to, this is a delta tetrahedral, right? So how it will look like, here it will be E and here it will be T2. So down we have 2 orbitals and upper side we have 3 orbitals, right? So how you are going to fill it up? For in this case, this will contribute 0 charge. So cobalt will have +2 oxidation state. It means it is having D7, okay? And tetrahedral complex, it is high spin. So 1, 2, 3, 4, 5, 6, 7, okay? So 7 electron we have, and then you just see one thing in this CFSE. Now it will be easy. So you know this is the berry center, okay, berry center. From berry center to down it will be minus 0.6 delta tetrahedral, and from berry center to top it will be plus 0.4 delta tetrahedral, okay. How this value we are writing, if you are not able to understand, just see my first lecture where this second lecture you see, where I have discussed this crystal field stabilization energy, right? For tetrahedral and octahedral. Okay. So now we have to just put it into the formula. So it will be minus 0.6 into how many electrons are there? 1, 2, 3, 4. So 4, and then plus, this will be plus 0.4 into how many electrons are there? 3. So it will be into 3, and then finally it will be delta tetrahedral, right? This value we are going to write it there, right? And then how much it is coming? Here it will be minus 2.4, and here it will be 1.2, okay, and then multiply by 70.638, correct, and then finally it will be minus 1.2 into 70.638. how much it is coming? I have already calculated. It will come around 84.3. 84.3 it will come. Okay, so magnitude they have asked, right? So no need to write this minus, directly you write 84.3. okay, so this is a numerical aptitude type question, so your answer will be 84.3. Discuss question number 18. okay, so what it says, question number 18 from the 2020. okay, the order of metal carbon bond strength. okay, here it is asking metal carbon bond strength, correct? So already we have discussed this type of question, but there we have discussed for carbonyl stretching, correct? But here it will be like metal to carbon. Suppose this is the what we have discussed. We have discussed this one, this carbonyl stretching frequency, and that depends on if charge is getting increased. okay, charge on metal, okay, charge on metal, if it is getting increased, means from negative to positive side, right? The oxidation number, positive side, if it is increasing, what will happen? This carbonyl stretching frequency, we can directly write carbonyl stretching frequency is getting increased, correct? But now in this question, particular question, they are asking this bond strength. okay, this bond strength. So what about this bond strength? It will be opposite to this. Like it will be like if the charge, okay, if the charge of metal is getting increased, your metal to carbon bond strength will be decreasing. okay, bond strength will be decreasing. So in this particular question, we'll see what it is given. okay, they have given chromium, carbonyl, and okay, and then second, what they have given, manganese, carbonyl, and then third, what is there in third? Titanium, carbonyl, 6, and then 2 minus, and then fourth one, they have given cobalt, carbonyl 4 times, and then minus. So likewise, how we have solved that particular question, we will solve here also. How to find the charge? So here we know that in this metal, titanium, it is minus 2. So like the charge increase, metal carbon bond strength is decreasing. So here the charge is lesser, right? Because it is minus 2, very lesser. So the bond strength will be more for third. And then this is single minus, so it will be like 4. And then it is not having any charge. It is first, and then coming to the point 2. So this will be your correct answer, right? Here the metal charge, whatever charge it is here, that will be the metal charge, right? Metal oxidation number. Why? Because carbonyl is a neutral ligand. Carbonyl is a neutral ligand. So whatever charge it is there in metal also, the same charge will be appear, right? Here minus 2, here also it will be minus 2. Here it is minus, in cobalt it will be minus, right? So this trend, which option it is following? Let me see. Option number C. Okay, so your correct answer will be option C. Okay, so moving forward to the next question, the question number 21, right? From the same year, let's see what they are asking. Question number 21. You can see in the screen, right? Question you can see in the screen. So question number 21, the complex which doesn't obey 18 electron rule, correct? Which one is not obeying 18 electron rule, that you have to find it out. So for that, this is question number 21. For that you have to find it out for all. So this is cobalt. Okay, here metal bond will be there. Okay, be careful about that. Okay, directly they are asking here metal bond will be there because 2 metals are there, right? So for cobalt it will be 9 because so many times we have solved. So again I am not going to write over there. So it will be 9 into 2, 18 plus how much contribution will be there? 2, right? because lone pair it is donating. So 2 into 8, it will be 16, and one metal bond will be there, and we know that in a single bond minimum 2 electron will be there, right? So plus 2. So how much it is coming? 18 plus this 16 to 18, 18 36. Now what you have to do, whether it's following 18 electron rule or not, so you have to just divide by n. So n factor will be here 2. So how much it is coming? 18, correct? So if it is divisible by 18, this way also you can do it. It's a simpler way. If it is divisible, completely divisible with 18, then it is following 18 electron rule, right? So it is already completely divisible, right? So now this A is following 18 electron rule. So the question is asking not obeying 18 electron rules, right? So now we'll see the option B. What it says, option B, it is having iron and then 4 carbonyl and then 2 minus, correct? So in this iron we know that valence electron is 8, right? So 8 plus each carbonyl will contribute 2. So 2 into 4 it will be 8, and plus 2 electron is here, right? So how much it will be? 8, 8, 16 and 2, 18. So this is also following 18 electron rule, option B. Then we'll see option C. Option C, it will be hydrogen and then manganese, okay? And then we have carbonyl, okay, 5 carbonyl. So it will be like, we have to find it out. So manganese, it will be 7, valence electron is 7, plus hydrogen will contribute 1, okay, plus carbonyl, each carbonyl will contribute 2. So 2 into 5, it will be 10. So 10, 1, 11 and 7, 18. So this is also following 18 electron rule. We'll see the option D, what it says. So option D, we have eta 5 C5 H5, okay, cyclopentadienyl. So in this meaning, what about the meaning of, like, if it is written eta 5, it means this 5 electron is contributing, correct? And then ruthenium, chloride, and then carbonyl and PPH2, right? Here, just be careful about this. They have asked PPH2, not PPH3. Okay, if they are asking PPH3, then this lone pair will contribute, right? If they are asking about PPH2, then the minus charge will contribute, correct? It is similar to, for this, we can say it NH3, this lone pair is contributing. For this, we can say it NH2, the negative charge is contributing, right? So, if this one is contributing, then 2 electron is contributing, right? If suppose minus is contributing, only 1 electron is contributing, so be careful about that. So we'll just calculate this one. So this will contribute 5 electron plus ruthenium. Ruthenium will come in which family? Iron family, right? Iron, ruthenium, osmium. So it will be 8, valence electron will be 8, and then chlorine, 1 electron it will contribute, carbonyl, 2 electron it will contribute, PPH2, okay, it is not PPH3. So PPH2 means 1 electron it will contribute. How much it is coming? 8, 5, 13, 14, 16, 17. So it is 17 electrons. So this is not obeying 18 electron rule. So your option D will be your correct answer, right? Which is not following 18 electron rule. So we'll move towards the next question from 2020. Next question is question number. Okay, question number 36. Let me check. You also try to solve. If you are able to finding any other questions, let me know. Okay, I will discuss it. Okay, if anything else, any more questions if you are finding there, even beyond 2019, like 2018, 17, 16 also, if you are getting any questions, let me know. I will discuss it, because concept is main, right? Question is not that much important, because question they are not going to ask. Question is only for practice purpose, right? So based on these concepts, if it is getting solved, you solve it. If it is not able to solve based on this concept, you just take the screenshot of that question and upload it in that YouTube comment box, right? If there are many, like 5 or 10 questions, if it is gathered, again I'll take one video class and I'll solve it, correct? So that much I can do for you, because your examination is in 12 February, right? So now question number 36 from the same year, 2020, right? The transition metal complexes with zero magnetic moment. So zero magnetic moment means Bohr magneton value, means mu is spin, only value is 0 Bohr magneton, okay? zero dipole moment. They need zero dipole moment also. And CFSE also they have given. CFSE equal to minus 2.4 delta octahedral. Okay, delta octahedral means this is an octahedral complex. Okay, R. Which one is following these things? Okay, where the magnetic moment is zero, dipole moment is zero, CFSE is this one. So it will, we have to see one by one, right? So option A, just we will write it down: manganese, okay, carbonyl 5, and then CS3. Correct. Just let me solve this one. Manganese we have like first for this kind of thing we have to just find it out the oxidation number. CS3 will contribute -1 charge. This will be 0, right? 0 charge. So how much? What will be the charge for this manganese? The manganese will be, calculate, X equal to X plus X minus 1 equal to 0. So X will be plus 1, right? So manganese plus 1. So how much it will be? B6, right? D6, and this is carbonyl. So strong field again, right? E2G, EG. So 1, 2, 3, 4, 5, 6. Okay. So everything is paired up. Correct? Everything is paired up. If everything is paired up, then there is no unpaired electrons. If unpaired electron is not there, then mu spin only will be equal to 0 Bohr magneton. Correct? Mu spin will be 0 Bohr magneton. But we have to see the dipole moment. Correct? Let me draw this molecule. This first part is following, right? First condition is fulfillment. Only the second condition we have to see. For manganese, we have to just draw. Okay, this is the octahedral complex. Let me draw. This is carbonyl, this is carbonyl, 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 and one CH3. It can't be zero dipole moment, right? Because this force is something different and this force is something different, correct? So it won't be zero dipole moment. Means this option can't be correct. Okay, option A can't be correct. Because here you can see it says dipole moment is 0. So dipole moment, this bond, it will be 0 because this force, okay, it is pulling towards both the sides. This force is also pulling, okay, opposite direction. This one, what will be given? This will be pulled down and this is giving, right? So this direction, net dipole moment will be in this direction, correct? So likewise, we have to see option B. Let me check the option B. Option A is not a correct option. So option B, we have to check it. Then option C, option D, okay, everything we will check it. So option B, what it has given? It has given trans nickel. I'll just write ethylene diamine. So En I'll write it, and then Cl2. Okay. So for nickel, first we have to see the oxidation state. This will contribute 0. This will be -1 into 2. So -2. So X minus A plus 2 into -1 equal to 0. Directly we can write -2. X equal to +2. So nickel, it is in +2 state. So it will be D8 configuration. Let me check. Here it is ethylene diamine and +2 state. It will be high spin complex. Okay. If it is +4, okay. If it is +4, then only it will become low spin. Otherwise, it will be high spin complex only. There won't be pairing up. So 1, 2, 3, 4, 5, 6, 7, 8. Okay. It means there are 2 unpaired electrons. So mu spin only value will be. It will be, let's see, it will be 2.83 Bohr magneton. So it is not equal to 0, right? So if it is not equal to 0, then this option is getting cancelled. We are not going to see your dipole moment, okay? Because this much, first step itself, it is not following, right? So now option C, we will see whether it is following or not. Option C. You also try it, okay, by yourself. Option C, it says trans, then it is cobalt, and then cyano. How many are there? 4, and then aqua, water 2, and here it is minus charge. Let me first calculate the oxidation number. Okay, cobalt X. This will contribute -1. So plus 4 into -1. This will contribute 0. Okay, so equal to -1, and then X. Here it will be -4. So if that side it is going, it will be +4. So X equal to plus 3. So oxidation number for cobalt, it is 3 plus. And if it is 3 plus, whether it's a 3 plus or 2 plus, if cyano is there, it will be a low spin complex, right? Means pairing up will be taking place because it's a strong field ligand, correct? So cobalt 3 plus, it will be D6. Okay. Let me draw T2G, EG. So 1, 2, 3, 4, 5, 6. See, there is no unpaired electrons. So mu spin value will be 0 Bohr magneton. Now we have to see the dipole moment. This I just write it down because I need that place. So mu spin equal to 0 Bohr magneton because there is no unpaired electrons. Now just let me draw this one. So this is cobalt and I know this is an octahedral complex. Okay, so we have to draw and it is trans. So trans means this water and this water will be opposite because 180-degree bond angle we have to make it, then only it will be trans. If it is cis, 90-degree bond angle will be there, right? So now just try to draw remaining cyano. So now you just see it is a 0 dipole moment. How? If this is pulling, this is also pulling, so it is cancelling out, right? These two are in opposite direction, it is cancelling out. Okay, here also see, if this one is donating, this is also donating. So what is happening? The groups attached are opposite to each other. So finally it will be mu equal to 0. So this one is following. See, your dipole moment is also 0 and spin only value also 0 Bohr magneton. Now we have to see the CFSE. CFSE always, see if you are calculating CFSE. Okay, but first two I have not calculated because that is not itself, it is not following this 0 Bohr magneton or 0 dipole moment, right? This question is very much easy. Any one factor if you are calculating, you will come to know whether this is following or not. Okay, so for this, these two are following, so I have to just calculate CFSE. It will be minus 0.4 into T2G. How many are there? 6, and then plus 0.6 into how many are there? 0 electron are there. Octahedral. Okay, so how much it is coming? It will be minus 2.4. Okay, delta octahedral. This side it will be 0. So minus 2.4 delta octahedral. This is also following. Okay, all the three conditions are following. So option C will be correct. Let me check for option D whether it is following or not. Option D. Okay, this is multi-selection question. Maybe option D. We don't know. We just calculate and see whether it's following or not. Okay. So option B, trans, okay, cyano, how many are there? 4, and then Cl2. I think trans and this thing is there, so maybe it is following. Let me check first. Oxidation number of iron, this will contribute -1, this will also contribute -1. So what will be the oxidation number? X plus 4 into -1 plus 2 into -1 equal to -4. So x, here it will be -4, -2, -6. So x equal to -4 plus 6. So x equal to +2. So oxidation number of iron is +2. It means it is D6. And cyano is there. So it will be low spin complex because cyano is a strong field ligand. It will be pairing up. Okay. So it will lead to pairing up. So let me check. 1, 2, 3, 4, 5, 6. So here also you can see Bohr magneton, mu spin value will be 0 because number of unpaired electrons is 0. Okay. So now dipole moment we have to check. What will be the dipole moment? I'll just draw it. This is a octahedral. Okay. And it is in trans form. So trans form is one chlorine will be here, another will be here, right? And then cyano groups will be available. So now you see these two are on opposite, these two are in opposite, these two are in opposite, correct? If all the like groups are in opposite side, then your dipole moment will become 0. Okay, these two conditions are following. Now third condition, CFSE, we have to calculate. So it is a similar type of the previous one, right? All the 6 are in down, so it will be minus 0.4 into 6. Okay, and that side we are not going to write because there is no electron, so it will become 0 that side. So delta octahedral. So how much it is coming? Minus 2.4 delta octahedral, correct? So all the three condition it is following, right? So option D will also your correct option. So for this particular question, option C and option D will be your correct answer, correct? Okay, question number 46, right? This will be the last question for 2020. Okay. This will be the last question in 2020. So, question is, you can see in the screen, the total number of all possible isomer of which is 46, okay, of cobalt, and then I'll just write En because this is ethylene diamine, okay, and then Cl2, and here is positive charge, and one more they have given, 2 they have given, and all together how many are coming, they are asking En, and then it is 3 and 3 plus. This charge is bond effect here, right? So together how many number of isomers are there, okay, that we have to find it out. So before that, that chart itself, it is not working because this is a AA type, right? This is a AA type, and what we have learned, that is MA, ML6, ML5A, ML4A2 or ML4AB, like that we have one chart, right? So likewise for AA also I will give you one chart, and then we'll discuss this question, okay? First I'll draw that chart and then we'll discuss it. So suppose if you are finding M, AA, B2, C2, okay? It means suppose here cobalt and here En, okay, only En, ethylene diamine, and then 2 ligands, 2 chloro, 2 bromo, likewise, okay? So total 2, 2, 4, and this is bidentate ligand, so 2, so total 6. So this complex is octahedral. So how many geometrical isomer will be there, how many optical isomer will be there, and total is stereoisomer, okay? So for this type of molecule, 3 geometrical isomer will be there, 1 optical isomer will be there, total 4 stereoisomers. Now second type is AA, okay, this will be 2, and then B2, I think this one is following in this category. So how many will be there? 2 geometrical isomer, 1 optical isomer, total 3, right? If suppose we will have MAA2 and then BC, okay, both the ligands, suppose here chlorine and water, okay, this one is En2, here if it is chlorine and water it is there, then what will happen? So here it will be 2, here it will be 1, total it will be 3. Next is MAA3, okay, this one, I think this one is falling under that category. So how many will be there? Geometrical isomer and 2 optical isomer will be there, so total 2 it will be, right? So this condition also you have to see how it's working. So now directly, no need to solve, I guess you will get it here itself, right? So this chart also you write it down somewhere, because if this type of question they are asking, you have to just convert this one. So how you are converting this cobalt, you just write metal, this En, you should know this is a bidentate ligand, okay? If it is bidentate ligand, just whatever is written you just write it down, AA2, and then this is B2. Now you just see AA2, B2. So how many geometrical isomer? 2. How many optical isomer? 1. Total isomer is 3. Now for this condition, how you are going to write? Here you write metal, okay? Instead of cobalt, write metal, and En, right? You know that this is a bidentate ligand. So this will be A. How many are there? 3. So MAA3, 0 geometrical isomer, 2 optical isomer, total will be 2. So 3 plus 2, how many are coming? Total altogether 5 are coming, right? So 5 will be your correct answer for this question, okay? Next question is question number 17, okay? So question number 17 we'll see, and this is from 2019, correct? 2019, question number 17. So 2019 we are solving now, question number 17. So here the concept it will apply trans effect. Okay, we'll see what is trans effect. So the correct trends in the rate of substitution of chloride by pyridine in the following complexes. Okay, before seeing this, we'll just discuss what is trans effect and then we'll come to the point. Okay, so trans effect, so it is like, it is generally it will take place in square planar complexes. Okay, square planar complexes. Okay, so suppose we have one metal and it have 4 bonds. Okay, suppose here ligand, and here it will be X and here it will be T, and suppose in this and this is a square planar complex, and if you see the field ligand, like the strong field ligand, okay, which group will be a strongest, like which will act as a strong field ligand. Suppose in this case T will be our stronger than X. In the spectrochemical series, T will come first and then X will come second. Okay, so in this type of reaction, what will happen if any group is coming for substitution reaction, so SN2 reaction. If suppose SN2 reaction is taking place, you know, right, SN2 reactions backward attack. So suppose Y minus is coming and this is a nucleophile. This want to come here and attacking to the this square planar complex. Okay, so what will happen? So if this one is stronger, so this will play a trans effect, right? So if this one is stronger, this will come and attack here, and this X will go away, right? Because this one is now labile group. Okay, labile ligand or group, you can say. So this one is labile. Okay, so now Y will come here and it will sit over here. So now the next your final structure will be, these two will be ligand, this Y will come and sit here, and this T is already it will be present over here, right? So based on this, one trans effect series I'll give you, and then 2 or 3 problems if you are solving, you will be master in this trans effect. So just you have to see which group is attacking and which group is going, that will be mentioned in a question. For this particular question, they have mentioned that the substitution of chloride by pyridine, okay, means here the pyridine will be the nucleophile, right? Instead of, I'll just write, instead of Y, they want pyridine. Okay, pyridine should be attacked here, and here instead of X, they are putting chlorine over here, right? So chloride is getting substituted by pyridine. Okay, so that they will mention in a question. So just you have to follow this trans effect series. Okay, so this will be like H minus or carbonyl. I'm just giving you, you just write it down, and 2 or 3 times you just see it. It will, you will be master of this. This will be PR3, and then AsP3, okay, and then CH3 minus, then phenyl minus, and then nitro, then iodine, then bromine, okay, then chloride, then pyridine. You see, then pyridine it is coming, okay, then pyridine, and then NH3, then OH minus, okay, then water, and finally fluorine. So in this trans effect series, fluorine will be in the least priority, correct? So now with this series, I'm not going to delete this series. With this series, we'll solve our question, okay? Let me check. So 4 molecules they have given. So one is, all the 4 I'll draw it here. So one is platinum, okay, here is fluorine, here it is PET3, here it will be PET3, and here CH3. So in this type of question, what you have to see, they are asking that chlorine is getting replaced by pyridine. So you have to focus on this place, and you have to see in its trans which group is there, okay. So based on this, the lability will be there. If it is stronger, then this will be labile, it will go up, okay, very fast. If it is weaker, then this will take time, correct? So this is, I guess, 1. Then we have platinum, okay. This is PET3, here it will be Cl, here it will be phenyl, and it is PET3, this will be structure 2, and then we have platinum, this is chloride, okay. Always you have to look into the opposite side of this labile group, okay, what is there, okay. Based on that, the lability will be increasing or decreasing. This is 3rd one, and this is 4th one, correct. Here is chloride, here it is PET3, and here also PET3, and this side it is hydrogen. This is structure 4. Now you just see, everywhere here it is chlorine, okay. So we have to replace this chlorine by pyridine, okay. With the pyridine we have to replace this chlorine. So for that we have to see which one is the stronger, means we have to focus the opposite of this chlorine, right, opposite of this chlorine. So here we have CH3 minus, here we have phenyl, here we have chloride, here we have hydride. So just you see this trans series, hydride will be the stronger. Okay, this will be the stronger. So if this is a stronger, then this will be more labile, right? Easily it will be like substitution will be taking place. So I'll just write lability order. Okay, for this chloride, I'll just write lability order. It will be 4, and then 4 will be more labile. That chlorine will be replaced very much fast. Okay, the reaction will be faster, and then after hydride, phenyl will be here. Before that, this carbanion is there. So this first will come. After that, this first will come, and then chloride will be here, and your phenyl will be here. So this 2 will come, and then 3. So wherever this order is falling, that will be your answer. Okay. So okay, option number A. Okay, just arrow mark is like it is starting from the least one is third, and then more is second, then 1, and then fourth will be the higher. Okay, so here also we have done 4 will be higher, then first, then second, then third. Okay, so option A will be your correct option. Correct. So we'll see the next question. Okay, so next question is question number 20. We'll solve it. Okay, question number 20. We'll see what they are asking. Okay, you can see in the screen. Okay, and try to solve by yourself. If it is getting, if you are able to solve it, okay, then it is well and good. Question number 20. The observed magnetic moment of an octahedral. Okay, we have to just write all our octahedral. Mn3 plus just some other information is also there. So iron 3 plus and cobalt 3 plus magnetic moment. Okay, so complexes are, this one is having 4.95. okay, this one is having 6.06, this one is having 0.00. all are in Bohr magneton. Okay, all are in Bohr magneton. This is the question number 20. Okay, I should mention it respectively. The correct option for the electronic configuration of, okay, they are asking electronic configuration. Just we have to write the electronic configuration based on this. So first of all, if it is 4.95 Bohr magneton, means there is 4 unpaired electrons. Correct. If it is 6.06, means there are 5 unpaired electrons. Don't go for 6, right? Because if it is 6 unpaired electron won't be possible. Okay, in octahedral. Okay, so it is 5.92. Maybe the orbital magnetic moment also they have added, right? What we are calculating? We are calculating mu spin only, right? Mu spin only. Maybe in this mu spin only, mu spin plus mu orbital, both they have added, right? If both they have added, I think plus 2.0 or something, plus or minus, no? Plus 2.0 you have to do it. Okay, if mu orbital is also they are adding. Not 2.0, sorry, plus 0.2 you have to add up, plus 0.2 or 0.15 you have to add up, right? So this will be your 5 unpaired electron. In cobalt 3 plus 0 means there is no unpaired electron, 0 unpaired electrons. Now based on this we have to draw. For manganese 3 plus, we know that it should be D6, D5, D4, it should be D4, correct? Because in plus 2 state it will be D5, so plus 3 means it will be D4. Now it is an octahedral, so just draw it, T2G and EG. So electronic configuration you need, and 4 unpaired electrons means it will be high spin, 1, 2, 3, 4. So this is 4 unpaired electrons. So directly you just write it down here, electronic configuration T2G3 EG1. Okay, for the second one you just take it, iron 3 plus, how much it is coming? For iron 2 plus it will be D6, for 3 plus it will be D5, correct? And they are saying all the 5 are unpaired, means it is also high spin complex, T2G, and it is easy. Just draw it, 1, 2, 3, 4, 5, right? So what is the electronic configuration? It is T2G, how many are there? 3, and EG, how many are there? 2. Now the next one, cobalt 3 plus. And okay, so cobalt 2 plus is D7, cobalt 3 plus is D6. Now what is happening? Just see T2G and EG. Now they are saying that 0 unpaired electrons, means Zero unpaired electrons means it will be like the unpaired, we have to pair up everything. So 6 are there, so it will be low spin complex, right? 3, 4, 5, 6. See, all are paired up, so it's a low spin complex. And what will be the electronic configuration? T2G6, Eg0. So let me check respectively which one is having. First will be T2G3, Eg1. T2G3 Eg1, option B, and then next will be T2G3 Eg2. Here T2G5, no, it is not there. Option C, T2G3 Eg1, and then T2G3 Eg2, and T2G6 Eg0. Option C will be your correct answer. Okay, option C will be your correct answer. Okay, let me see the next question. Okay, next question we will find it out. Next question, if any other questions are there, you can directly approach me. Okay, let me see question number 45. Okay, question number 45. What this is a numerical aptitude type from 2019. Okay, question number 45. Okay, so the value of n, okay, for the complex, okay, directly they are asking value for n. It will be like carbonyl 4, and then instead of carbon they have written that silicon Me3, and okay, here they have put n. So this n value, based on that, this and it is 18. It is following the 18 electron rule, right? Satisfying the 18 electron rule. So total overall it should be 18, right? Then only like this side it will be 18. So this n we are going to plus it here. So iron, how much valence electron? So it will be 8, correct? Plus carbonyl 2 into 4, it will be also 8. Here it will be 1. So 8. How many are there? 8, it will be 16, 1, 17. So 1 electron we are adding here, right? So when we are adding 1 electron, when it is here, when it will be minus, right? If it is plus here, then we are doing negative, correct? Or else you can write it like this, equal to this n you take, okay? Equal to this n you take, okay? And this you can write it this minus, just do like this, 8 plus 1 minus 18 equal to n, or you can write 17 minus 18 equal to n, or n barabar minus 1. Okay, so your answer will be minus 1. So minus 1 you have to fill up, don't put 1. Okay, you have to put minus 1 here. You have to write minus and then 1. Okay, the sign is very important. If you are writing simply 1, that means they will think that it will be plus 1, right? And that will be wrong answer. So this type of question you just put minus 1, correct? So this will be your answer, minus 1. And after calculating, if you are not satisfying whether it's a correct answer or not, just minus 1 it came here. No, so just see that whether now it is following 18 electron rule or not. So just put 8 plus 1, and this one it came minus 1, right? So put this minus 1 you have to add it up here, right? So 1. So how much is coming? 8, 16, 17 and 1, 18. So now it is completed. So here it will be minus 1. Your answer will be minus 1, correct? So finally we done all the questions, correct? So is there any leftover questions is there? So directly you can approach me, I'll solve it. For help you need, whatever topic you want to discuss, you just tell me in a comment, I will arrange. And before the exam date, like we have the duration, right? Today is 1st February, and then we have another approximately we can say 8 or 10 days, okay? Because previous examination you will be having your own preparation, right? That time you won't watch YouTube and all. So you just go through with these questions, whatever concept I have given you. So everything I have covered in this coordination chemistry. And one more thing, you just don't find it out that okay, this concept is not covered. So see, this will be a big lectures, okay, lecture series. Out of that, I'm just taking out those important concepts which is very much important for your upcoming examination. That's why in 3 lectures, and today is the 4th lecture, I have completed everything for coordination chemistry. And it's a big chapter, right? You see how many questions they are asking each year. Okay, so watch it, and I have created a playlist. Go there and do the revision thoroughly, okay? Watch, I think 2 or 3 times you watch, you will be master of those concepts, correct? So thank you very much for watching.